Hello and welcome to the second common session of Sunoikisis Digital Classics Summer Semester 2018. Today is the second common session of this second part of our semester, and today our guest is Patrick Burns from the Institute for the Study of the Ancient World, New York University. Patrick, welcome. And Patrick has been contributing a lot to the digital classics community. This is his first session for Sunoikisis, so I'm very happy that he's with us today. And the topic is the Classical Language Toolkit today, which is an open source Python package for textual analysis and natural language processing for ancient languages. And you have, as usual, the class outline on GitHub with a YouTube link, slides, a description of the class, and exercises that Patrick will explain later. I would also like to announce an event led by Patrick tomorrow in New York City at the Institute for the Study of the Ancient World, Future Philologies. I will add the link to this event on GitHub in the page of his class outline. But as for now, so Patrick, welcome. Thank you for contributing to Sunoikisis.
Well, no, thank you, Monica, for the invitation, and I'm glad I've learned so much over the past couple of years from watching the Sunoikisis DC videos. I'm very happy to participate and share my work on the Classical Language Toolkit. And so let me just share my screen here. As this talk will really be in two parts. One, I'll give a slideshow with an overview of what the Classical Language Toolkit is and what we hope to accomplish with it. And then in the second half, I will take you through what I call a text analysis pipeline of getting from text as raw data all the way to admittedly a simple visualization, but the idea of going from text to text analysis to visualization, that's the goal for today. And then I'll talk a little bit about contributing if anyone is interested in to the Classical Language Toolkit. So let me bring up the slideshow here. Okay. We can see that now. Great.
Yes, we can see them. If you can start.
I thought it would only be fair to give you a little background about who I am and why I would be talking about this project. And so, first of all, again, Patrick Burns. I got my PhD in classics from Fordham University in 2016, having written a dissertation on genre in Latin poetry, and I was specifically interested in the influence of the Latin love elegists on Lucan's epic poem, the Bellum Civile, and you can see the title there, Amor Belli. I talked about elegiac diction. I looked at themes, erotic themes of love in the poem. And if you're familiar with this poem, it might not be the most obvious candidate for it's a very violent poem, sort of a grotesque amount of violence. And so,
Patrick, can you click on the slideshow, because we are okay now. We are at the right slide, but okay, present. If you can click on present,
yes,
we can see only, I think.
Oh, I see.
No, yeah.
Hold on, I see what you're saying. My side.
Did you share the entire screen? Because when you have two options when you share the screen, one is the your desktop. I don't remember. I never. Okay, now I see your slides, but I see the Google slides. If you can, because otherwise in YouTube it's too small.
I see.
Click there. Does it work?
Yes, I see it. I just I'm not seeing an option. Okay.
Okay.
I think that present opens it in a new window, so you'd need to share that new window.
Okay. My apologies.
No problem. It happens.
No, okay. No, sorry.
Okay, perfect. Now it works. Yeah.
Well, no. I think
For me, it works. I can see just the slide. I don't know if for other people it works, but
you see the slides now.
yes, it works.
Wonderful. Okay, so back on target. Sorry. Yeah, so I wrote a dissertation, and it became apparent to me as I wrote this dissertation what I really needed to do was to do some widespread computational analysis on genres, what makes a genre, specifically what words go into making a genre. And after some work at Tufts in 2012, I was introduced to the world of topic modeling and other analysis techniques that could give me the ability to compare large amounts of text to each other. And through this, I got involved in Python programming. But what I found very quickly was that the kind of work I did wasn't necessarily, it was basically all optimized for, I mean, to be perfectly honest, English, some other languages, but certainly not Latin and Greek. And so my first entry into this was writing pre-processing tools for Latin-based text analysis. And that is where I met Kyle Johnson, who is the director of the Classical Language Toolkit project, who was working on a project at the time called Ancient Greek and Latin for the Natural Language Toolkit. And that's what evolved into the CLTK. And the two of us have been working on this for the last few years together. The CLTK web address is cltk.org. Also, I write quite a bit about the project and about my other text analysis work on Twitter, especially so you can find me at DIY Classics. Okay, so what is the Classical Language Toolkit? A quick overview. Well, as Monica said in the introduction, it's a free open source Python package. And what we're looking to do is support text analysis and natural language processing for a fairly broad selection of historical languages, right? So we're looking at, I think Kyle recently set the cutoff as anything in a language before its entry into the print age. So I mean, it would depend on the language. But we're looking at historical languages writ large, both in a temporal scope and in a geographic scope. And we think of ourselves as building basic language resource kits for these languages. That is putting together the corpora that are necessary to do any sort of study on the language, but then building the tools that are necessary to analyze the language. And you'll see here, that's going to be the sort of tokenization, that is the splitting of a large amount of text into any number of smaller units, paragraphs, sentences, words, etc. Lemmatizers, that is getting dictionary headwords automatically from text. We want to do some speech tagging, morphological parsing, etc., etc. And at this point, Latin and Greek are certainly the most fully functioning, especially Latin. But active development goes on in many languages. So that was what is. Who is? Well, we are an open source community, and so anyone who wants to join in on building tools, collecting resources, defining workflows, etc., can go to github.com/CLTK and see what's on offer. Help us with our work there. It was founded by, as I said, Kyle Johnson, who has a classics degree from NYU and is currently working as a natural language processing research scientist. And we do have academic advisors in many different fields of digital classics. And then we also have an interface project called the CLT Archive, which is separate from the core tools that I will be showing today. But these are developed by Luke Hollis. So what does the CLTK want to accomplish? Well, our first goal is to get corpora in order so that you can't do any text analysis until you have text. And so for Latin, Greek, we've had quite an uptick in the Indic languages, Sanskrit, some interest recently in classical Chinese, et cetera, et cetera. We just want to have the corpora in place for doing the work. From there, we want to start putting together the building blocks for analysis towards a quantified classics. And this is the sort of tool building that is necessary, as I presented in the last slide. And the high aim for the project is it says here, framework for integrated study of the ancient world, a truly comparative digital classics all in one environment. It's an aspirational goal, you know, to be redundant, but we are working to do that. The project began in 2014. You can see our commit numbers. I love this slide because every time I show it in a presentation, all of these numbers tick up just a little bit. And so we have more and more people interested, more and more people contributing. We're on our 83rd release. We put out DOIs for every release so that we want to be able to support, insofar as possible, replicable digital classics as well. So you should be able to access whatever. If I were to do if I were to publish some material using the CLTK and you wanted to replicate my results, I would want to be able to point you to the same version. And I'll point out at the bottom of this slide, you will also see that for the last 2 years and for the upcoming year, the Classical Language Toolkit has been a participating organization for Google's Summer of Code. This is a project that Google has to support open source development for students. I was the recipient in 2016. We have had archive work and core tools work last year. Last year's project was in Old and Middle French, and we hope that to be able to share the projects for 2018 within the next week or so. Okay, as I said earlier, the Classical Language Toolkit is a basic language resource kit, to borrow Crowder's term, and he defined that as what is the minimum amount of what is the minimal corpus that you would need to be able to do any work in a language? What are the absolute basic tools that you would need? Again, the tokenizers, the lemmatizers, the morphological and POS tagging. And then from having the combination of corpora and tools, we start to build a collection of skills. And these are the sort of thing that I'll be showing in the second half of this. As I take you through the pipeline, you'll see how we go from having the text available, having a way in which to analyze the text, and we get we build a pipeline. This is sort of work I do on a daily basis of figuring out what needs to be done to set myself up for doing innovative philological and literary critical work in Latin and Greek. This slide, in fact, needs to be updated a little bit, but this is what I call the Blark in progress, a little chart to show where we've been. There was aggressive corpora collection in the early stages of the CLTK, so that is filling out nicely. You'll see that Latin has something pretty much in every column. Greek is also fairly well supported. There is, in fact, now a word tokenizer for Greek that should work fine. And recently we've seen quite a bit of work in stop list development, something that I've been doing research on over the last 6 months. So you'll see the community is also is research driven. So the research interests of the people working on the project will often define which tools get added. By the way, this is a little bit of an aside, but I've long wanted to put together what I've called, for lack of a better term, a Blarkathon, where each month we pick a tool that could use, say, greater fleshing out, and then we, in the spirit of these, say, these Wikipedia hackathons or things like that, where we just say work on the POS tagger for a full month and see how far we can get in all of the languages. We did see something like this last month with an informal Swedish Blarkathon, we could say. The Swedish are these, it's very interesting, these comparative word lists that go across different languages, almost completely modern languages, but we saw the contribution to the CLTK of at least 20 or so Swadesh lists for the project. So I think stop lists are going to get developed soon, but I'd love to see some tokenization work, say later in this year. Okay, and so that is the introduction. That is what the Classical Language Toolkit does, what we hope to accomplish with it. And now I'd like to take you through, I prepared a Jupyter notebook that is available online. You should be able to use it directly in the browser. And so if you were to go to this link, and I can leave that up for, say, a minute so you have time to get there, I'll take you through what I would say is a typical workflow for myself when I do my genre analysis. Before I can get to the point of doing any work on genre, I need to get the text in order. I need to pre-process them. I need to do some basic analysis of what I have. I might do some exploratory visualization. And so I'll take you from, again, text to visualization. Okay, so I'm going to leave this, and I will share a different screen here. Monica, before I share this next screen, I see there's the group chat. Is that where I should look for questions? Is anybody?
Yes, yes. Usually in the end, people or they talk or they put questions in the chat. You can also put links there, and I can add the links in the YouTube video. Yeah.
I see. Okay. Well, that's good to know. Thank you. Let me share this next screen. This is the Jupyter notebook for what I'm calling the CLTK pipeline. Okay, and you can see this?
Yes, yes, perfect.
Okay, so we'll move into the second part of this presentation, what I'm calling building a text analysis pipeline with the Classical Toolkit, Classical Language Toolkit. I've put this into what's called a binder. That's the link that you had should go straight to a binder, which will allow you to run the notebook code entirely within the browser without any installation. So all the models, all the corpora, all the code should run right there. And I tested it this morning, so I'm optimistic that it will still work. If you did want to, say, go to GitHub, you'll see that in my DIY Classics GitHub directory, there is a project for Sunoikisis DC CLTK. You could, for example, go in and clone this, and it's set up with through pipenv, and so you'll see down here if you run pipenv install and say pipenv shell, you would be able to bring up your own local copy, but you shouldn't need to do that for today's work. And then I also put here, this would happen in the pipenv install, is that the packages you would need to be able to use this would be Jupyter. That's the notebook environment that I'm working with right now. And I've seen that you had some, you all had some experience with that in recent Sunoikisis DC classes. You will also need to install the CLTK for a local copy. And then for the visualizations, we'll use matplotlib. We'll also use the natural language toolkit quite a bit in today's presentation, but the NLTK is a dependency of the CLTK, so simply installing CLTK will get you the NLTK as well. And so let's begin. So again, the pipeline I want to go through today takes us from one, getting texts, which is, we can't analyze anything until we have something there. Then we want to do the absolute basic pre-processing. We want to make sure that any texts that we work with, that we're going to use for any comparative work, are normalized so that they are truly comparable. So I'll show you basics of pre pre-processing. We will look at tokenizing, and specifically tokenizing into sentences, and then tokenizing into words. Both wind up being very useful for different text analysis tasks. Then I'll go into a little bit of an explanation on lemmatizing. This is an area which I have specifically spent a lot of time over the last year or so. So perhaps we'll dwell on that for just a little bit longer. And again, lemmatizing is the automated retrieval of dictionary headwords for any word. I work mostly out of plain text. The English example, if we saw the words go, going, went, gone all on a page, we would want to return the word go as the lemma, the word you would look up in the dictionary for all of those terms. And so I'll show you some examples of lemmatization in Latin. And then part of speech tagging, this is, you know, we may have two words, let's say, again, to use an English example, lead the verb and led the noun. We have strategies for figuring out when those four letters are a noun and when they're a verb. Otherwise, you know, things like the are much easier to spot. We'll look a little bit at that process. And lastly, once you have all of these building blocks in place, the building blocks of further analysis, we can then go about doing things like, say, creating charts, creating visualizations, and we'll look a little bit at that. So again, just to scroll down, if we were working on a local environment, you would want to install. We do not need to do that if you're working in the binder. And then, like in any Python environment, there's plenty of strong tools available in the Python built-ins, but we'll be bringing in our own packages to do some work. Something like request.html we will use to get some text. We also will use different CLTK packages for Latin-specific analysis here. Depending on what language you work in, you maybe would substitute for any of these tools, say Greek for Latin or something else. And then again, I said matplotlib we'll use for doing some basic plotting of our frequency counts. So we can run that. Again, just I know that you've all had some exposure to Jupyter, but just a quick explanation of what's going on, just basically on this entire page. Jupyter notebooks are sort of the they're increasingly popular for sharing data science work and this sort of analysis work. And they have a little bit of a, say, a word processor feel as we work from the top to the bottom in going through our argument. And this is code as argument. And you can highlight any cell. You see this is now, that cell is highlighted. Now this cell is highlighted. Now this cell is highlighted. And you can run the code either by pressing the run button up here, or we have a shortcut of Shift and Enter will also run it. You'll see every time you run a cell, you get this number will go up. This just shows you the order in which the cells will run. For today, we'll be working mostly top down, so this shouldn't affect us much. But if you ever needed to retrace which cells were run, you could say, well, we know that cell 3 was run before cell 6. Okay, the first working piece of code that I'll show here is I do want to set up one CLTK tool that we'll use for pre-processing. This is what we call the replacer. This is going to be a normalization function that takes any J's that it finds in Latin text and replaces them so that they are I's, or any V's will be turned to U. Again, when we want to be able to compare texts in any meaningful way, we want to make sure that they're normalized to each other. Okay, and so now we can begin in earnest with step 1 of the pipeline. And so you'll see here, I have a section called Getting Texts, right? We want to be able to get texts. We're going to pull this text off of the internet. You'll see I've given an example of a file that you could, you can go to this page and you'll see that it has, the Latin library is just filled with all sorts of plain text. But not necessarily, if we're doing text analysis, a couple of things to just look at before we continue. This is clearly text we might be interested in, but are these line numbers? Probably not. Is this a table of contents index sort of thing? We probably don't want that either. This is a title. I'm not sure we want that. If we scroll all the way to the bottom, we have some more paratextual material that we want to get rid of. So we'll take a turn at that. All right. So again, we had here imported from request underscore HTML the class HTML session. Let's build a session and then request that for that session, we're going to get this URL. So let's run this cell and then this cell. Worked. And we'll see here that we've saved that session information in a variable called R. R has an attribute called HTML. And as we run it, we'll see that, yes, we have received something. We have received, this is the object description, HTML for that URL. That in itself is perhaps not that interesting to us. So let's save the text of the HTML to a variable we call Cicero raw. Okay, and I will now print. I'm using pretty print, so we get a little bit of the P and the print, pretty print. I want to say take this variable Cicero raw and print from the 0 character to the 1500th character, the first 1500 characters of Cicero raw. And you will see what we have. We have sort of the title. We're not going to really want that. We don't want this title information. We have a whole bunch of numbers that refer to sections. We have this sort of these chapter markers. And then this is really what we want. We want to get down to this text. Okay. Yeah, so that's the first 1500. You see, this is sort of a nicer view of it. We may also consider for our own sake, let's see what the last 1,000 characters looks like. We'll see a whole bunch of text that we're going to be interested in getting. And then again, this is the paratextual information from the Latin library that we probably don't want. Okay, so we have text. The first goal of the pipeline has been met. Next, once we have text, we want to pre-process it. Looking back at the text that we have looked at so far, look at this first. It seems I can make a few general statements about it. We likely don't want to keep these chapter markers here, and conveniently they are numbers. We don't really want a lot of numbers. We're going to work with words today. So when we go to pre-processing, we might want to remove numbers. But the first thing we really want to get rid of is these paratextual materials that the Latin library includes that are at the, again, this is the bottom of the page and up here at the top. We don't want any of this information. So let's go about finding the start and the end, the textual information that we really want to work with. We look back up here. We'll see this is the first word, cum e CLTK decedens. We want there. And we can use Python slicing to start here by finding. We could find Pume Kilikia, for example, or we could find, say, this one in brackets. Okay, and that's what I've decided to do. I want to find a starting point of the first chapter. I'm going to save it in a variable called start. So I use the find method. Cicero raw, which we defined above, being just the HTML text, is a string, and strings have find method. Find will return to us the number of the character position as a number for where 1 in brackets appears in the text. So that seems like a good place to start our slice. Again, a slice is of a Python string is any smaller subdivision of that string, starting in one place and ending in another. How are we going to find the end? Well, again, if we scroll back up, we know we want to get it somewhere around this 333 marker. And so what I did here is perhaps a little bit more clever than necessary. I want to find the first, I decided to find the first new line character. This is a carriage return, a break in the text, okay? And I'm going to start that find from where it finds the number 333. So whatever position it finds, 333, it will go here, get that number, and then says, where's the next break in line? And it will find here. So that's how we know it will cut off our text right there. And with any sort of slicing of text that you find basically at random on the internet, there's a little bit of an art to getting start and ends. I'll let you, in the exercise that I presented for today, I said to go out and get some of your own text and run through this pipeline. You may have to come up with creative solutions for finding the start and end of any bit of text that you find. But you'll see that I've printed the start and end positions. So we know that the text that we want starts at the 1,265th character and ends at the 171,954th, right? So we can now create a variable called Cicero text that is a slice of Cicero raw at that start position and that end position. We can run that. So if we were to then rerun some prints of Cicero text as opposed to Cicero raw of just the first 100 characters, and then we'll skip a couple lines. And then of just the last 100 characters, we'll see we have exactly what we wanted. We have the text we need to do analysis on this bit of Cicero, which is the text of his work on the history of oratory at Rome called the Brutus. Okay. So that is just getting rid of paratextual material. We've gotten the text we want in shape, but now we want to do the sort of other things I was talking about earlier, where we want to normalize this text into you really can't pre-process text until you know exactly the research questions you are working on. So take this with a grain of salt. All pre-processing will have to be somewhat customized from here. The research question, the very simple task I'm going to work on at the end of this notebook is I just want to get a word count. I want a frequency distribution of the words in Cicero's Brutus. So I want to know how many times cum appears, how many times a appears, how many times Kilikia appears, et cetera, et cetera. So what I want to do in the next round of pre-processing is get rid of anything that does not contribute to answering that question. I don't need numbers. As it turns out, I won't need punctuation. And I don't want these letters, I don't want these words to be capitalized. For example, Python strings would recognize cum with a capital C is different from cum with a lowercase c. That's clearly not what I'm looking for. And then again, before I made reference to loading up a normalizer, a replacer for V and U and J and I, and so I will also want to normalize that in case that's an issue in our text. So let's go down and see what happens with our text processing one step at a time. The first thing I'm going to do is lowercase all of our text. This is fairly straightforward. I'm going to save in a variable called now Cicero underscore pp for pre-processing. I want to take Cicero text and apply a string method called lower. So Cicero text lower, we'll see the difference between that and that. We just have changed the case. This will take care of that counting problem of, say, the initial parts of sentences, where we want to catch both upper and lowercase chrome. As I said, we don't want numbers. There are many ways in which we can find and replace numbers in Python strings. I just gave one here. We can create, say, a string that has all the numbers. Strings, like many things in Python, are iterables. And what I mean by that is you can create for loops over strings that will go one number at a time, 0, 1, 2, 3, etc. And take action on each element of the string one at a time. So we can create a for loop that says for each number in the string numbers. And here we have our block, an indentation format for Python, a colon at the end of that, followed by an indented line. We want to assign, we want to say that Cicero underscore pp is going to be equal to whatever exists of Cicero pp at the time, and we're going to replace the current number. So in the first iteration 0, the second iteration 1, etc. We want to replace it with a blank character. Okay, and so if we run that, we're going to get again, we're going to print the same variable, but it will have been altered from the previous cell. And we can see that the number 1 has disappeared. Mind you, I'm only printing the first 100 characters so that I don't take up too much room on the screen, but rest assured, all of the numbers from this document have been removed 0 through 9. Also, I mentioned earlier that I didn't want any punctuation. There's a string method called a string attribute called punctuation, which we could use, but it's roughly equivalent to this. So I thought it would be more meaningful for you to see it. So we can define punctuation as this long list of characters, to which I want to add a couple that I happen to know from doing work on the Latin library will appear. And we will add these 2 characters to that. And we can do the same thing. We can iterate over each character in this string and replace that punctuation where it comes up, an exclamation point first, a quotation mark, by the way, an escaped quotation mark next, number sign, etc. Replace that with a blank space. And again, I run that, and you'll see those brackets are now gone. The period that followed the Q is gone. The comma following ablatum is gone. All right. And we want to normalize it using our replacer. This, in fact, will just, oh, no, you can see we have Venissim here with a V. We run, oh, I never ran that cell above. Give me a second. You see, this blank here indicates that it is an unrun cell. We can run that. Go back to where we found our error. I think it's very good to see errors in real time. We found out from the trace back that replacer had never been defined, and we were able to take easy action to correct it. Okay, and now we will see that again, our one line at a time, we're going through function by function to pre-process this text. We now have all of our V's have been changed to U's so that we can make sure that some Latin text editors choose to retain the V, sometimes they do not, but we want them to be comparable across texts. Lastly, this is perhaps unnecessary, but it's nice to keep things in order. I replaced all of these the punctuation, the numbers, etc., with a blank character, which has now led to a number of long gaps that seem somewhat unnecessary. So I'm going to just clean up the spacing from my own, I just want it to look nice. So there are many ways in which you could replace spaces. One fun way, and I think it's fun, would be to say split our string. And if you split without providing a character here, it splits at every space. And then we can use the join function attached to a space. So it's going to now just put one space where every break existed previously. And you'll see we have a nicely pre-processed text of Cicero's Brutus that we can now use to do things like get frequency distributions. You would never want to go through that line by line. I did this for educational and illustrative purposes, but in fact, it would be a much better idea to write a script. Here I've defined a function called preprocess that takes any bit of text, like we were doing Cicero underscore pp, and it will go through all those same steps, returning, giving us as an output the final product of preprocessing. And we can see that if we were to go back to Cicero text and run that same 100 characters, that we get the same output from running just the preprocess script. Okay. Moving right along. Actually, hold on 1 second. I'm going to get to tokenization and lemmatization next, but I thought maybe I've been throwing a whole bunch of Python at you in a steady stream. I thought I'd check in on the group chat to see if anybody has any questions so far. It'd be somewhat of an statement. It's amazing how much of my life I spend processing text. That is.
Okay, there is a question in the chat.
Yes,
Anise from Brazil.
Okay. Yes, let's see. And so, Anisa, are you running a local version, or are you doing it through the binder? Okay. Yes. You might need to run pip env or pip install request underscore HTML. If that didn't work, I'm not exactly sure. I will be happy to, all the pips, I like that. Yes, this is why I've switched to using Binder for these sorts of things, because setting up local environments can be tricky. You feel free to be in touch with me about that. I've not had any problems in the past in installing request HTML, but yes, maybe there are localization issues or something like that. I'd be happy to work with you and look into it. And that's an open offer as well to anybody who's tuning into this. I am easily reachable. You can find me on Twitter at DIY Classics. Through my Institute for the Study of the Ancient World email address, in my NYU address there. Feel free to send me any questions that come up. I love working through this stuff with people. I want more people using the CLTK for all of their language work, and so I'm happy to support it. Another thing I'll get to right at the end of this talk is like a good open source community. We have issues enabled for CLTK. When you find errors in your work, post an issue to GitHub, and I will be happy to review it and be in touch with you about fixing it.
Thank you, Patrick. Thank you for that.
Yes, I know. It's there's many levels of complication. First of all, philological work in general is can be yes. theoretically tricky. So we're already starting from a difficult textual science. then to add Python and then specific Python packages to the mix. There's endless complexity, and I'd like to minimize difficulties where possible. So if there aren't any more questions, I'm going to cut back to the notebook so we can look at tokenizing and here I've taken Cicero text, which I've split by the new line characters. I just want to get a sample paragraph to work on. And here's paragraph 60 of the Brutus, and I've picked it for a specific reason. We're going to be tokenizing by sentences, and we have periods in different places that are doing different things, and so I want to illustrate the necessity of using the right tool for the right job. Okay, so we pre-process that text, and we'll see we've removed, we've lowercased it, removed punctuation, et cetera, et cetera. Now I said here that I want to tokenize sentences. You'll see that with the pre-processing script, and as I mentioned earlier, we always want to use a pre-processing script that meets our research question needs. It looks like it's going to be very difficult for me to break this up into sentences. Not impossible, but difficult because I've removed all of the punctuation. So in fact, let's rewrite a pre-processing script, which we will call preprocess 2. Okay, so we have our punctuation, and then we'll take out a period. We use replace to take out a question mark and say an exclamation point. I don't know how many exclamation points there are in the Brutus, but we'll get rid of them. And so now you'll see we have basically the same pre-processing function, but it is left in what we would need to be able to tokenize by sentence. For example, we want to make sure that this breaks and this breaks, etc. Okay, the Natural Language Toolkit has a sentence tokenizer that is very good, and we'll use the Punc tokenizer. The one thing we should be aware of is, as I mentioned in my introduction, pretty much all of these tools were tuned on English models. And there are other language models available, but rarely historical language models. And so let's just use an English model to see what happens. So we're going to load this tokenizer. This is the sentence tokenizer called sent tokenize. We'll get all of the sentences into a variable called sense. And then I'll go through, I use enumerate so that I can count, and then list each sentence. Okay, if you have any questions about that, I'd be happy to answer. And so we have gotten our information, and we'll see that sentence 1, it has correctly identified. It is correctly identified sentence 2, 3, and 4. And so Punc tokenizer is a probabilistic tokenizer using information from a trained model that has, luckily enough for us, it's actually a complete coincidence, has recognized that the P and the M here are abbreviations. And so good for us here, an NLTK tool tuned for English satisfied our Latin needs. And you'll see if I run the CLTK instantiation of the same thing, we get the same results. I show this example to you mainly as a warning because sometimes just because you get correct results from an English model on your foreign or your historical language text, it does not mean that you always will. So we should be happy that we got this result, but not confident in it. With the Latin-specific models that we're given here, we should be both happy and confident. So that's an example of how we can use the CLTK to split sentences. But for the rest of this presentation, it's going to be much more important that we get word information. And there are many ways in which we can tokenize words. For example, we can simply split on space. That seems like a perfectly fine idea. Here's some random tokens from the middle of Cicero PP, 75 to 100. And this looks all right. Let's make it smaller. But you know what? I'm not thrilled about this. Bonorumque. I want this to be bonorum, and I want to split the que because I want to be able to count later instances of bonus. And we see the same thing with conjunctissimusque. So splitting on space is actually a bad idea, as there are all sorts of these things that pop up when we do word tokenization. The classic English example would be how do you tokenize can't or won't? It's a really tricky one. What do you do with apostrophes and contractions? The NLTK word tokenizer, again, this is one that is tuned for English, will do some of that work for us, but basically for this set of text, it's going to give us back the same thing. And so, again, a case for why we might want to use a word tokenizer, and this is the CLTK tokenizer for Word, that is tuned specifically on a Latin model. We load word tokenizer with a language parameter. Okay, and then word tokenizer has a method called tokenize. We run that on our Cicero_pp variable that pre-process text of the Brutus. And then for those same tokens, it takes a little bit longer to run, we'll see that we get the same text, but bonorum has been split into its own token, que has been split into its own token, conjunctissimus has been split into its own token, etc. And so again, depending on your research question, but if mine here is counting Latin words, I certainly want to get that. I want to get these separated. Okay, so and I know some of you are working in Greek or other languages, and you will all have these specific tuning issues for your language. I invite you to look into what's on offer and contribute that sort of grammatical domain-specific knowledge that you have and to the project so that we can increase the number of word tokenization models that work per language. Okay. So once we have a list of words, we now, in Cicero tokens, we have a list of all of the words, not split by space, but split according to space and certain Latin tuning parameters. We can go to the next step of lemmatizing. And lemmatizing is a tricky prospect. Homonyms create all sorts of problems. There's also all sorts of ambiguous forms in a highly inflected language like Latin and Greek. And again, we will use a probabilistic model, which I'm loading here. It just takes a second to load. Okay. There are instructions for installing the models on the CLTK site. And then we have, I'm going to use one of the lemmatizers that I wrote called the Backoff Latin Lemmatizer to look up the dictionary headword for each of the tokens in this string. So again, for those of you who know Latin, debebam, we want debeo, agebas, we want augeo, etiam remains the same, molestiam is going to get molestia, etc., etc. And so we want to have a systematic way of doing that. CLTK offers that sort of tool. So just give 1 second for the lemmatizer to load. Okay, and we see, we know that something is finished when we get a number. While it's running, it is an asterisk. The lemmatizer is now loaded. We can take our tokens and we can lemmatize them. And we will see, using the probabilistic model that I have, it's a combination of many models, and I'll explain that in a second. But we have gotten some token lemma pairs. And again, I told you we're looking for debeo, for debebam. We see that. We see exactly what we want. The lemmatizer has a roughly 91% accuracy rate. This section looks pretty good to me. This conjungo is interesting. This is coming from a dictionary. I'll explain that in a second. But things are looking okay for us doing automated lemmatization. I showed you here that the specific lemmatizer I loaded was a CLTK product called Backoff Latin Lemmatizer. The Backoff Lemmatizer is in fact not a single lemmatizer, but is a series of progressive lemmatizers, and I've explained here what it does. You will see, and in fact, it works backwards, it backs off. So it tries different lemmatizers. So we have one called the train lemmatizer, which uses training data to figure out the highest likelihood of any token. Again, I'm trying to see this as an example here. I can just give you one in Latin. Cura, it could be the noun cura. It could be the ablative or the nominative form in plain text that's unmarked. And it could also be the imperative, singular imperative, care. But if we look at the statistics on the language, it's going to be that noun, I don't know, 99.x% of the time. Our training data will bear this out, and if Cura was in the training data, it would return to us the correct lemma of Cura the noun, and then it would stop. It would return that lemma. If it didn't find anything in the training data, you'll see it has a back off command here. Back off means that if you don't find something here, you try again on a different one. So it backs off to number 5. Regular expressions are used to check the endings of Latin words in this lemmatizer. Again, it will go through all the regularly occurring patterns, and if it finds one, it will return that lemma. If it does not, it will back off to another one, etc. And so the unigram lemmatizer uses a different set of training data. And then we have a principal parts lemmatizer, which is the regular expressions lemmatizer, but also is aware of principal parts for Latin, those core verb forms, and can give us even more accurate information. And then we have another dictionary-based one that is based on the Morpheus forms. That's where I think this Conyungo form is coming from. The ones that you would say find in the Perseus word study tool. And then if it finds nothing at the end, it will just return the identical form. We find that by the time you reach this part of the lemmatizer chain, simply returning the form as is, it gives a slight bump to your accuracy. So that is how we do lemmatization in the CLTK. It's often very handy, especially in a highly inflected language, to not just work with token counts, again, just the words as they appear in their forms in the text, but to get our feature counts up, we will combine forms so that amor, amoris, amorum, etc. are all under one feature to be counted together. So that is the purpose of lemmatization, and that is how it exists. I'm just going to quickly show you that we have part-of-speech tagging. I'm running a little bit short on time and want to show you a quick visualization. So we do have POS taggers. There are a few implemented, and here I'm going to, again, run ones that are trained specifically on a Latin model. Again, something you won't find in the NLTK or in other text analysis or natural language processing packages, which commence the use of the CLTK. And we'll see that once we have this tagger, we can use, for example, something that's called a TNT tagger and see what kind of tags we get back. And we'll see this is not inspiring a whole lot of confidence at the moment. I think most Latinists would be able to return a form for debebam pretty easily. It comes back as unknown. At least they call it quad magna as an adjective. I printed the Perseus tag set, which is being used here, so you know what is being returned. But again, conjunctissimus, this is the difference between having a probabilistic model for determining information and having, say, a philological model, and this is ongoing work on my part. We can also run a CRF tagger, conditional random fields, and see this actually inspires much more confidence on this model. It'd probably be the one I would use if I were using POS tagging at this moment in time. We see a much greater, I don't know, Cognitismus is not a noun, but this is inspiring more confidence than less, and so it's something to play around with. I haven't worked extensively with the POS tagger at this moment. It's something I hope to spend more time on next year. And here I just pull out the first letter of all the tags in a dictionary and in a list comprehension so that they're in a pair, so we can compare it. The accuracy seems okay here. So something that's available in the CLTK, not maybe as well tested as the Tokenizer or the Lematizer, and certainly someplace where if you were interested, you could contribute to the project. All right, in the last minute or so that I have here, let's just go about one analysis task. Now that we have our list of tokens, we have our list of lemmas, et cetera, we can do some interesting things. For example, I can use the counter function in collections to just get token counts for what we have in Cicero. And so from the Brutus, we learn that et appears 937 times in 597, et cetera, and it goes down. This is interesting. This looks very complicated. This is mostly just print formatting, but what we can do is fairly easily, and you can copy this for your own purposes, create a running count of that, so that we have our top 25 words in Cicero's Brutus built again in the pipeline from the raw text, pre-processed, tokenized, lemmatized. We've built up the ability to create an accurate word count. We have our raw count for each word, what percentage of the total number of words it is, and then a running count. If you're familiar with Zipf's law, this should not surprise you that this number descends the way it does, and that the top 25 words of the Brutus account for nearly a fifth of the text. In fact, it would probably be useful. Know how many tokens are total. So there were 25,340 tokens. So 20% of them are accounted for in just the first 25 words. Okay. And lastly, here I'll say that NLTK has a class called text, which will, once you have a list of tokens, such as we have prepared in the CLTK pipeline, we can get some things working very quickly right out of the box. So we'll bring in text. We'll take Cicero tokens, wrap it in text, save it to that variable Cicero text. And once we have an NLTK text object, we can do things very easily like create concordances. So here's all the instances. Oh, here's the first 25 of 43 instances of the word Brutus in our text, and we find some interesting things like classic concordance, interesting things, stuff like tum seems to appear before the word Brutus very often. I wouldn't necessarily have expected that, and it's not necessarily the kind of thing you might get from a continuous straight reading of the text. We can also do things like create dispersion plots using NLTK text. And so here I have the terms Brutus, Cotta, and Caesar, three people who appear in the text. And we get a map, narrative time at the bottom, okay, 0 being the first word, 25,000 or so at the end here. We'll see that Brutus appears often throughout the text and well distributed. Cotta doesn't seem to appear in the beginning, but has, you know, high amount of frequency here, but so continuous but intermittent. And then Caesar, if you know the Brutus, appears somewhat famously in this section here. I can tell you exactly what that is, and then rarely. So we can get these sort of maps very easily once we have our token list. And lastly, we can do things like get a graph of that chart that I showed you earlier using frequency distribution on our NLTK text object. And so here is the first 50 words in a easy to see chart. Et, again, being making up, what do we say, it's like a 900 words or something like that. There's 937 ets. That's where this starts. And then we see sort of how the cumulative number of words appears. So the first 50 words make up 8,000 or so tokens. I'm going to leave it there. You've gotten a good sense, I believe, of what some of the basic work of the CLTK is, what it can do to get you started answering more important research questions you might have than simply getting word counts. But counting is probably the basic philological operation, so I feel like I've left you in a good place. Let me just say that in the exercise I gave you for this week, I've asked you to find texts of your own that you want to work on. If you're interested in Latin, we had loaded the Latin library earlier in this. I just wanted to show you that there's a file IDs method here, and I've only shown you the first 25 in this list, that will show you all of the text that you have here. If you wanted to get the raw text of any one of these items. And maybe we only want the first 100 words. Right? You can put in anything that appears in file IDs here, and you'll get some text to work on, and you could go through that whole pipeline, again, using a text that's not the Brutus, see if you get interesting results. And say you wanted to work with a Greek text, you could always create yourself a triple quoted string in Python. I can say go to the beginning of the Iliad to get a Greek text. Put that in here, and now you'll see now we have some Greek text to work with. There's many ways of getting text in. Once you have text, you can work on it with the pipeline that I gave you. Last thing I'm going to show you is that the CLTK has something called a quick start for contributors that will take you as an introduction to, well, I've shown you what the CLTK is, but you may want to contribute. You may want to find out more about what we do on a more technical basis, or you want to learn how to use Git to interact with the CLTK. That can all be found on this page at github.com/CLTK. It's on the wiki, so you can check there. It's also in our syllabus sheet for today. I believe that I am now out of time, so I'm going to go back to my camera. And am I back? I'm back on camera now. Yes.
Yes, you are. So, Patrick, thank you very much. Excellent.
I took you through a lot. I tried to go slow in the beginning so that anyone starting from very little or from nothing at all could follow. Again, I'm available in many channels. So if you have questions about anything shown in this notebook or the CLTK in general, I'm more than happy to answer those. And if you have any questions right now, I'd be more than happy to talk about them.
Okay, thank you. I don't know if there are any questions. We still have people in the Hangout. I don't see questions on YouTube.
Aha.
Yes, Anise, yes.
Mm-hmm. Okay, so the question here is about named entity recognition and lemmatization in Greek. The questioner has asked, I plan to practice how to do that using the existing Greek libraries. Also, how to extract proper names from the list quoted that resulted from NER without quotes, etc. Oh, so you want to clean the results. And so I will take the liberty to write to you for help. That is fine. You could do that. There are NER modules available in the CLTK. I put those in the category of the POS tagging modules. They are there. There's basic functionality there, but they have not been tested thoroughly. So I see that both as a challenge and an opportunity. One, the challenge is out of the box. You may get surprising results, and they might be somewhat disappointing. The opportunity is that if this is a project that you're interested in and that you have expertise in, that makes you the perfect person to contribute to making the tools better. And I'd welcome that, and I would be very much interested in helping you both figure out the logic behind the models that CLTK uses for named entity recognition, and for that matter, lemmatization, as you are combining them here. And then we have a micro-publication workflow. Anything that's contributed through GitHub gets author credit, and we'd be happy to credit you for that that expertise you bring to our project. So preemptively, welcome aboard, and happy to work with you on both of those things.
Okay, thank you. So you mentioned a micro publication.
Sure.
Can you explain that? Maybe this is a new word for our people in the community.
That's fine. What I mean by micropublication in the classical language toolkit setting is that, and I will say it's also it's a complicated thing in the CLTK as well. We represent so many different languages and so many different expertises within the languages that the contributor base for CLTK is disparate. We have many people working on very specific things. So it's unlikely, for example, I work on the Latin tools and the Greek tools. I do not work so much on the classical Chinese or Coptic tools. What I mean by micropublications is that when you share that expertise, either in the domain of language or in the domain of text analysis and NLP, we will include an author credit for your contribution for accepted commits through, for accepted pull requests through GitHub. And you can be assured that at the top of each of the page, any of the authors who have made contributions to the work that have been, if they've been accepted, they'll see that credit. They can refer to that credit. I believe Kyle has also worked out a script to scrape all of the pages for a master contributor list. So we have some people contribute more than others, but we value all contributions, and we want to give credit where credit is due. And so those are, you could work, for example, on, someone has been working recently on the classical Chinese stopwords module. He will get a credit at the top of that page and could add it to his CV, for example, as a project he worked on, and he could point directly to the credit in our repo. So.
Thank you for explaining that, because in our community we have been talking a lot about producing micro publications, but I think it's still important to explain what we mean by that. And definitely, so I think this is a great model for building a collaborative environment where everyone can be, can have credits for his or her contribution. So this is important. Yeah,
we view, in fact, maybe it's something that I really love about the project is we view ourselves, of course, as an open source computational technical project, but also as a genuinely open source academic project. And like any good academic, I cite the things that I refer to, and I would like to have credit when I contribute something as well. There's a sort of a nice give and take to the process. And so, yeah, it's as an academic project, I would expect credit to be made explicit, and I mean, I want our work to be citable, and citable specifically by contributor.
Definitely, and this is very important, and this is a new way of publication, going beyond the traditional way of publishing in the academic world. And of course, a big problem is how to assess, how to evaluate these kind of contributions. But now we have many examples, so really, I think this is an important contribution. One last thing, we still have 1 minute. I don't know if there are questions in our group. So speaking of contribution, so there is a wiki, an excellent wiki, so people, students who want to start, everyone can learn. But what kind of contributions you need. So you mentioned languages. Of course, you are a classicist and you work mostly with ancient Greek and Latin, but I imagine you need contributions about different historical languages and other expertises. Can you mention now what do you need now? Or I know it's a big question. Maybe.
I mean, the project is young, and it's young enough that its concentrations have been mostly centered around its most active contributors. So Kyle founded it as someone in a traditional classics program in the U.S. So he has certain Latin and Greek competencies. Same here, and so. That's no coincidence that those tools and even the corpora are maybe more fully developed. But in fact, we'll welcome contributions across the language range. And one of the most important activities for the CLTK that I've been involved in over the last year is figuring out ways in which to build a genuinely comparative philological model for contribution. I've dubbed it object-oriented philology, and you'll hear, if you follow my my Twitter, you'll see much more about this in the coming months. But the idea that we will create, say, basic classes for stop lists, and then the refinements will take place on a language basis below that. So we override classes, override methods within within those modules as demanded by specific languages. This does two things, and it should make contribution much easier. One, it compartmentalizes language expertise. I work on the Latin tools, somebody else might work on the classical Chinese tools. There may be some people who work on both, but we found from the contributor base overall that people tend to work on specific details. This way, with this setup, someone doesn't need to go into the code for the other to make their contribution. And this separation of function should reduce bugs and smooth the way towards making contribution more direct. The second thing that it does is, no, I've lost my train of thought here. But it also it gives us just a clear, it's somewhat of an ontology for making the organization of languages clear in the directory structure of the project. You can go on GitHub now and go to CLTK, go to the submodules, so stop, tokenize, lematize, etc. And then increasingly you'll see in those folders Latin, Greek, etc. And that sort of a tree structure should make it easier to just differentiate how the languages function within the project.
Okay, excellent. Thank you. So now, unfortunately, our time is over. But really, Patrick, thank you for this great conversation. No, thank you.
I enjoyed it, and I'm open for questions even when the window closes. So
I'm sure you will get many
100%
and thank you for this. And another thing, so Patrick tomorrow will lead a Future Philologies event. It is an event at the Institute for the Study of the Ancient World, but the program is online. As far as I understood, Patrick will publish something after this event information. Anyway, you can find the program online on Twitter. And I think that this title, Future Philologies, is very, very, very interesting and promising. So, okay, excellent. So next week we will have our third common session. James Tauber from Eldarion will present the Scaife Digital Library Viewer, so which is a new project launched a few weeks ago in March. So thank you again, Patrick. Well, good night for the community in Europe. Good. Have a good lunch, I think, and good afternoon to you in the US. So thank you again, and see you next week. Okay. Bye. See you. Ciao.